Where it starts to get a bit funky is where you mix these things together. Okay, so example. Let's think about this. We'll go with x minus 1 and let's add x plus 1. Okay, so we're adding two functions together. There's a couple of ways to go about this. I can do the algebraic route, okay, and I will do that in a second, okay? But I want to try and appeal to the visuals if I can, because that's a very powerful way to understand things, okay? So I'm going to draw my graph. I'm going to take a bit of a shortcut because I already know what the absolute value of x minus 1 looks like. It looks like this, okay? So it's just like the absolute value of x, but it's being moved over a little bit, okay? So because this graph I'm about to draw is not my final graph, I'm going to put that in a lighter color. So if you can maybe just lightly pencil it in, here it is. Okay, so there is the absolute value of x minus 1. Okay, both parts of it. Okay, how is the absolute value of x plus 1 different? Okay, well, instead of starting with x minus 1 and then making it bounce, I'm going to start with x plus 1, which kind of looks like this, right? And then that bounces. So in fact, it's going to look like this. You can see it's the absolute value of x, but it's being moved that way instead of that way. Okay, so far so good? Okay, now keep in mind, right, I've got here two branches of this one with different equations and two branches of this one with different equations, okay? So in fact, this is where I'm going to put in my proper equations now. This one's x minus 1. Oh, sorry, this one's x minus 1. This is 1 minus x. What about this one? What's this equation here? It's just that branch, the right-hand side. That's x plus 1, right? And then on the other side, I've got minus x minus 1. Right? It's going down. It would have hit here at negative 1. Okay? So now, to add these two together, I think I've got all of these different cases to think together, right? Let's do this piece by piece. Okay? We know that this intercept here is negative 1 and this is 1. Okay? So for the case where x equals negative 1, this graph will be equal to 0. See that? What will this graph be equal to? You can even see it, can't you? Because I've drawn it reasonably accurately. What should this value up here be equal to? It should be positive 2, right? Look, there's 1 and then 2. Yes, so 0, 1, 2. So I'm up to 2 here, right? Now if I go 0, this graph plus this graph, 0 plus 2 is equal to 2, isn't it? So when I add these two graphs together, the sum of these two graphs will be here. Does that make sense? I can replay the same thing over here. Watch. I'm adding this green graph and this green graph, right? This one's equal to 0 down here. And it's equal to, well, it's symmetrical. Should also equal 2, right? So I'm going through that point. Now, I'm just going to stop for a second because you're like, hold on, what just happened? Let me just verify this for you just with the numbers. When x is equal to negative 1, what's this thing? Well, y is equal to the absolute value of negative 1 minus 1 plus negative 1 plus 1. See that? I've just substituted in negative 1. That's all I'm doing. Okay. So what happens here? What's inside the absolute value?
Minus
2. Negative 2. What's inside this absolute value? 0. And the absolute value of negative 2 is, sure enough, it's just 2, like I expected. And I can replay this again. If I substitute in x equals positive 1, I'll still get 2. Okay? All right, now, think with me. We'll do it visually, and then we'll do it algebraically. What's happening in this middle section between here and here? One graph is going down. It's decreasing. The other graph is increasing. And one's decreasing at exactly the same rate that the other one is increasing. Okay, so let me give you a picture. Okay, you remember the input and output valves for our tank of water before, right? And something's coming in, something's coming out. So what this looks like is, I've got like whiteboard markers, okay? And I put them into a box, and as soon as I put one in, right, I'm increasing, someone else takes it out and decreases, right? And then I put the next one in, increase, and then at the same time, someone takes one out. So what's happening to the amount of whiteboard markers in my box? It's staying the same. Every one I put in, someone takes one out. Every time this graph goes down, this graph goes up. So the net effect is no change, right? Which is why, if I started at 2, I'll stay at 2. Okay? Now, If you're like, what just happened? I'm going to do it again algebraically because you already know. Shh, stay with me. You know what the equation of this branch in here is, right? Let me write it in closer just so you can see it. 1 minus x, right? So 1 minus x going down that way. What's the equation of this one here? It's x plus 1 going up, right? Well, in this little section here, in this domain, if I add this, 1 minus x, and x plus 1, the x's cancel and all you get left with is 2. So the equation of my new middle section is y equals 2, which of course you know is a horizontal line. Okay. All right, now, again, visually, then algebraically. What would you expect is happening over here on the right-hand side? Don't shout it out, just think with me, because some of you already have it, I think, because you've seen this kind of graph before. Let's go back to my whiteboard marker example, right? There's not a decrease and an increase anymore. What's happening over here? This is increasing and this is increasing. So it's like two of us putting whiteboard markers in, right? So not only should I expect it to increase, what rate should I expect it to increase at? Twice as fast, right? Which as a gradient would be 2 because the gradient of this is 1 and the gradient of this is 1, all right? So that's the visual. Watch it happen algebraically, right? X plus 1, x minus 1. Plus 1 and negative 1, they cancel out. All you get left with is x plus x, which is 2x. Now the great thing about this, you see this, if I've drawn it accurately, if you get a ruler, let's see how well I've done. I should be able to bring this back, well, I was a bit off, but anyway. It should be going through the origin, just like 2x would normally, right? Except I'm in a restricted domain. You see that? I'm only equal to 2x on this side. Now, before I do anything, look at the symmetry of this thing. I'm not even going to do any argument. What do you think's happening on the left-hand side? Same thing, but in reverse. What do you think its equation is? Negative 2x, right? And how can you tell that algebraically? You take these two guys, right? This positive 1 and this negative 1 will cancel, just like these ones did. And all I'll be left with is negative x minus x, which is minus 2x.